Here in this session we will discuss about problem on transformed impedance. It is a continuation from the previous topic. See, here we will discuss a problem. In the given network, the switch S is opened at t equal to 0. The steady state having established previously. With the switch S open, draw the transform network for the analysis on the loop basis representing all elements and all initial conditions. Write transform equation for the current in the loop. This is the circuit diagram. It is given that 10 volt is a battery source, 2 ohm resistance, 4 ohm resistance, 1 Henry inductance, 1 farad capacitance value, and there is a switch S. See, let us go to the question again. In the given network, the switch S is opened at t equal to 0. See, here the switch S is opened at t equal to 0. That means it is the instant where switch is open when t equal to 0. That means at t equal to 0, there is no connection of this portion of the circuit with this voltage source, right? See, at t equal to 0, switch is open. That means there is no connection with this voltage source. So, this circuit portion will be isolated from this voltage source 10 volt. Right? So, again you can go to the question, and it is given that the steady state having established previously. That means before time t equal to 0, steady state has been achieved. That means before time t equal to 0, switch will be closed. That is given in the question. That is, switch is closed before t equal to 0. At t equal to 0, switch is open. Before t equal to 0, switch is closed. That means there is a connection with 10 volt before t equal to 0. When this voltage source is connected to this switch before time t equal to 0, then there will be a current flow through this circuit. Okay. So, there will be a complete current flow through this circuit. The current will flow through this inductor, current will flow through this capacitor, etc. So, when current flows through this circuit part, you know that initially inductor will offers a resistance to this current, then it will allows the flow of this current through the inductor. So, up to the time t equal to 0, there is a current flow through this circuit. That means a steady state is achieved up to t equal to 0. That means when t becomes 0, at the time t equal to 0, the current flow will attain a steady state value. That means at the steady state, the nature of the inductor is it will become short circuit to current. Similarly, the capacitor become open circuit. When steady state is achieved, the important thing is that under steady state condition, the capacitor is open circuited and the inductor is short circuited. When capacitor is open circuited means that the entire 10 voltage source will appear across this capacitor, and means complete voltage will appear across this capacitor because it is open circuited. When a current flows through this capacitor, that means it starts charging. So, the charging increases the voltage across the capacitor. So, when the steady state is achieved, the capacitor acts as an open circuit and the complete 10 volt source will act across the capacitor. Similarly, when steady state is achieved, the inductor flows a current through it. When the steady state is achieved, inductor acts as a short circuit to the source. That means the complete current flows without any resistance through this inductor. So, that is the behavior of the capacitor and inductor under steady state condition. So, you should remember that the inductor will be short circuit in steady state and capacitor will be open circuited under steady state condition. That is the important thing. Okay. So, when the steady state is achieved, you can draw the diagram like this. See, before time t equal to 0, the switch is closed. So, you can redraw the circuit as 10 volt will be connected to this circuit portion, right? When steady state is achieved, here you can see switch is closed at before t equal to 0, and the current flows through this inductor part. Inductor becomes short circuit. That means I have drawn it like a straight line. Inductance part is shown here, but because it acts like a short circuit. So, I0 be the short circuit current through the inductor. Similarly, at a steady state, the capacitor is open circuited, so it is not shown there because that circuit portion is open and complete input voltage appears across this capacitor or open circuit. So, under steady state, the current through the inductor can be found out by simple Ohm's law. See, if you are considering this loop, you can find that current through the inductor I0 will be equal to voltage divided by resistance, that is 10 divided by 2. So, initial current through the inductor under steady state condition is I0 equal to 5 ampere. Similarly, the capacitor is open circuited, that means the complete 10 voltage appears across the capacitor. So, under steady state condition, the voltage across the capacitor V0 equal to 10 volt. Okay. So, these are the initial conditions because you know that before time t equal to 0, the current through the inductor is 5 ampere and the current through the voltage across the capacitor is 10 volt. So, this is the initial condition. So, now you are analyzing the system or analyzing the circuit at a time t equal to 0. You know that at a time t equal to 0, the switch is open. So, 10 volt battery will not be there in the circuit and the rest of the circuit portion will be this, right? This is the circuit. So, at t equal to 0, this will be the circuit and you can draw the transform impedance circuit for this circuit portion. Okay. 10 volt source will not be there, but this part of the circuit will be there under steady state condition under when t equal to 0. That means when t equal to 0, the circuit will be, this 10 volt source will not be there in the circuit and the rest of the portion will be there. And you are asked to find out, see in the question you are asked to find out the transform equation for the current in the loop. This is the loop and you have to find out the transform equation for the current in this loop. So, you can first draw the transform impedance circuit. See, this is 2 ohm. You know that impedance, transform impedance for the resistance value is resistance itself. So, instead of 2 ohm, you can write it 2. So, this is 2. This is the transform impedance value for the resistance. Next, there is again another resistance 4 ohm. The transform impedance value for this 4 ohm is 4 itself. This is 4. Next, you have the inductance value 1 Henry. This is 1 Henry. So, instead of L, you can draw an inductor in series with a voltage source and inductance value will be Ls and a voltage source value will be L into I0. So, instead of that inductor, you can draw the transform impedance circuit as an inductor in series with a voltage source and inductor value will be Ls and voltage source value will be L into I0. Ls value is, L value is 1 Henry, right? So, 1 into S will be the value of this inductor and this voltage source value will be L into I0. L value is 1 and I0 value is 5, that you have find out, that is I0 is equal to 5 ampere. So, you can draw L into I0 will be 5. You should note down the sign because you have derived the circuit symbol in the analysis portion and it is shown that first negative sign comes then positive sign comes. So, Ls in series with this voltage source will give 1s into 5. Similarly, in this capacitor portion, you know that you should know the drawing of this transformed circuit for this capacitor and instead in the case of capacitor, this capacitor will be replaced by another capacitor in series with a voltage source and series with a voltage source and that capacitor value will be 1 by Cs. Here C is 1, so 1 by Cs will become 1 by S and voltage source value will V0 by S and you have find out that V0 is 10, so 10 by S comes here. So, you are asked to find out the transform current and transform current is in the direction like this. So, transform current value is equal to Is since it acts as a series circuit, right? This is a series circuit. So, total current will be equal to total voltage divided by total impedance. Here total voltage is, if you are considering the current direction like this, total voltage will be 10 by S plus 5 and total impedance will be 1 by S plus 4 plus 2 plus 1S. So, you can write the transformed current is equal to 10 by S plus 5 divided by 1 by S plus 4 plus 2 plus S. So, that value will be equal to 5 into S plus 2 by S square plus 6S plus 1. That's all about this problem. Thank you.